We're given a circle O of radius 10 meters, which is this circle over here. This circle is inscribed inside an equilateral triangle ABC. Here's our equilateral triangle ABC. Then we are told that a circle R, it is tangent to the circle O. Here we go. This is circle R, which is tangent to the circle O, and the circle R is also tangent to the segments AB and AC. This is segment AB, this is segment AC, and this is your circle R, and this is circle O. We're asked to find the radius of the circle R. This problem might look easy at first, but don't be fooled by its looks. This is actually a very clever problem. In fact, this kind of problems have been asked on math competitions before, so pay attention. Let's see what we are given here. We are given that the radius of the circle O, it is equal to 10 meters. Radius of the circle O is 10 meters. We're asked to solve for radius of the circle R. All right. Now to solve this problem, we need to build some background first. We need to remind ourselves of a few basic properties of geometry. And they are, for one, the center of a circle that is inscribed inside a triangle is called as the incenter. All right. So the first thing is incenter. What is incenter? Incenter is the center of a circle that is inscribed inside a triangle. Inscribed inside a triangle. And if this triangle, it happens to be an equilateral triangle, as in the case of this problem, in that case, the center of the triangle, center of the equilateral triangle actually, is equal to the incenter of the circle that is inscribed inside this equilateral triangle. Okay, now since we are talking about equilateral triangle, the centroid of the triangle is equal to the center of the equilateral triangle. So let me put this again here. We're given a circle O that is inscribed inside an equilateral triangle. That means the center of the circle is going to be equal to the center of the equilateral triangle. That is a basic property of geometry. And since it is an equilateral triangle, the centroid of the triangle is equal to the center of the triangle. So now we have two things. One, the center of the circle equals the center of the equilateral triangle. And then we're saying that the center of the equilateral triangle is equal to the centroid of the triangle. That means the center of the circle is equal to the centroid of the triangle. Make sense? I hope so. We're going to define what is the centroid of a triangle in just a minute. But before that, I want to make sure that what I have just gone over has sunk into you. And that is, we said that center of the circle O. Okay, so this is like my circle here. It is equal to the center of the, how about I just write EQ dot for equilateral triangle. Center of the circle that is inscribed inside a triangle will be equal to the center of the triangle only if the triangle is an equilateral triangle. And 2, if it is an equilateral triangle, then the center of the equilateral triangle, it is equal to the centroid of the equilateral triangle. So basically what we're saying is here, that something here, this, let's call that as A, is equal to whatever it is, let's call it B. And this B here, it is equal to something called as C. So A is equal to B and B is equal to C. What does that tell us? That tells us that A must be equal to C. So that means the center of the circle O is equal to centroid of the equilateral triangle ABC. All right, so this is a very important statement over here. Let's now define what is the centroid for a triangle. All right, so to do that, let's draw a triangle. So here we go. We have a triangle. Let's call this triangle as ABC. What we're going to do is we're going to draw a straight line from each vertex to the center, to the midpoint of the opposite side. For example, from the vertex A to the midpoint of the side BC. This is called as the median. A triangle would have 3 medians. The second median, we're going to take it from the vertex B to the midpoint of the opposite side AC. The third median will go from the vertex C to the midpoint of the opposite side AB. Wherever these 3 medians intersect, we call that point as the centroid of the triangle. So for this case, this is O. O is the centroid. And if I draw a circle over here, O is also the center of the circle with the center O. Center of the circle that is inscribed inside the triangle ABC. Okay, now we are going to get into another fact, and that is the distance from the vertex to the centroid, which is AO. It is twice the distance from the centroid to the midpoint of the opposite side. Let's call this point over here, where the straight line coming from A is intersecting the midpoint of the opposite side, BC, as the point D. So what we have just said is this. The distance from A to O. This is the distance from the vertex A to the centroid O. This is twice the distance from the centroid O to the midpoint D on the opposite side, BC. All right. Now this OD. OD is also equal to the radius of the circle O. Which is given to be 10 meters. All right. Let's do one thing. Let's call this point on the circle where the median going from the vertex A to the opposite side BC is intersecting the circle as E. So this line, this median, that is going from the vertex A to the midpoint of the opposite side. That intersects the circle O at 2 points. One point is E and the other point is D. All right. Now what we're going to do is we're going to say that AO is equal to AE plus EO. Now, what is EO equal to? EO is nothing but the radius of the circle O. And we know its value is, 10 meters. So that gives us AO is equal to AE plus 10. Now this AO, what is AO equal to? AO is equal to 2 times OD over here. And OD we know is equal to 10 meters. So what would be AO equal to? 2 times 10, which is 20 meters. So 20 equals AE plus 10. From here, AE is equal to 10 meters. Now hold this for a minute while we move to the next part of the problem. Let's now move to the real part of the problem. Now we are going to move to what we're actually asked to solve for, and that is find the radius of the circle R. To solve for the radius of the circle R, let's do one thing. Let's draw a line, a horizontal line, that is parallel to BC and is tangent to both circle R and circle O. Let's now go ahead and label it. Let's call this as E is already taken, FG. Okay. And this point up here, this point where the green line AD, it is intersecting the yellow circle at the top. Let's call that as H. So here we go. This is our H. Now, if you look at the triangle AFG, then you will notice that this angle AFG, this is same as the angle ABC. Also, the angle AGF is same as the angle ACB. And this angle A, it is shared by both triangles AFG and ABC. So basically what we have shown is that angle AFG is same as angle ABC. Also, the angle AGF is same as angle ACB. And angle FAG is same as angle BAC. So of course, the triangles AFG and the triangle ABC, they are not same size, but they are similar triangles. That is, the triangle AFG, it is similar to the triangle ABC. That means if triangle ABC, it is an equilateral triangle, that means triangle AFG must be an equilateral triangle as well. So if the triangle AFG is an equilateral triangle, then whatever arguments we made before to solve for AE, we're going to use those same arguments again to solve for the radius of the circle R. Let's see how that is done. So here you go. So here's what we're saying. We're saying that for equilateral triangle, which one? AFG. Center of the circle R, which is inscribed inside this triangle, is same as the center of the triangle AFG. That is because this triangle is an equilateral triangle. And since this triangle AFG, it is an equilateral triangle, that means the center of this triangle is same as the centroid of this triangle. So from here, what we get is this: the center of the circle R. Let's make a copy of this. Is same as or is equal to the centroid of the triangle AFG. So let's scoot this a bit down here. Here we go. We're going to make use of this equation here now to solve for the radius of the circle R. How? This is how. We know that the distance from A to E, it is equal to 10 meters. How? We have already solved for it right here. So we are going to just copy it down here that AE is equal to 10 meters. Then we're going to say that the distance from the vertex A to the centroid, which is R, for this triangle AFG. So AR is equal to twice the distance from the centroid R to the midpoint of the opposite side, which is E. Now we know that RE is equal to the radius of the circle R. That means AR is equal to twice the radius of the circle R. Now this AR, it can also be written in a different way. AR is also equal to AH plus HR. Now what is HR equal to? HR is also equal to the radius of the circle R. And this AR, we know that it is equal to 2R. So here's what we're going to do. In place of this AR, substitute 2R from this equation over here. So let's go ahead and write AR as 2R equals AH plus HR. HR is equal to R. So from here, what is AH equal to? AH is equal to R. All right. Now we're going to look at this entire length over here, AE. What is AE equal to? It is equal to 10 meters. But we know that A is made up of three separate distances that are AH plus HR plus RE. We know that RE is equal to the radius of the circle R. HR is also equal to the radius of the circle R. And this AH over here, we just showed that that is also equal to the radius. So basically, what we have here is radius, radius, radius equals 3R. So here we go. What do we have? We have AE, which is 10 meters, equals 3R. Can we solve for R from here? Sure can. So what we have is this. AE equals 10 meters equals 3R. Equate these two. 10 meters equals 3R. Divide both sides by 3 and we get R is equal to 10 over 3 meters. So here we go. The radius R of the smaller circle R is equal to 1/3 of a 10 meter. This is our answer.